Good morning. Today we'll solve the examples on root locus. Sketch the root locus. With open loop transfer function. G of s is equal to k into s plus 1, and this is a s square plus 4s plus 30, and here solution. So whenever the open loop transfer function is given, we have to find how many open loop poles and zeros are there. Okay, the open loop poles are at s of s is equal to -2 plus minus j3. Okay, so these are the roots of this equation. And the open loop zeros are, there is only one open loop zero at s is equal to -1. So therefore the n is equal to is equal to 2 and m is equal to 1. So n is the number of open loop poles. These are 2, and the number of open loop zeros is 1. Okay. Therefore, we have to find the asymptotic angle. Theta A is equal to plus minus 180 degree 2q plus 1 by n minus m, where this q is equal to 0, 1. Okay, so as the n minus m is 1, therefore we have to substitute here only the value of 0, and therefore if we substitute here 0 in this equation, q is equal to 0, we'll get plus minus 180 degree, and n minus m is 1. N minus m is 1. Okay. So the next we have to find the breakaway points. Are the solution of dk by ds is equal to 0. So here we have to find like this. So 1 plus g of s h of s is equal to 0. Therefore 1 plus g of s is given as k into s plus 1 divided by s square plus 4s plus 13. H of s is here 1. equal to 0, and therefore this q is equal to minus of s square plus 4s plus 13 divided by s plus 1. Okay, we get like this. Now we have to differentiate this with respect to s, and we have to equate it to the 0, and therefore the differentiation of this is plus 1 square is plus 1 into differentiation of this is 2s plus 4 minus this s square plus 4s plus 13 into 1. Now we have to solve this further. So this is a 2s square plus 4s plus 2s plus 4 minus s square minus 4s minus 13, and that is equal to 0. Okay, so this 4s will cancel, what will remain? Minus 2s plus 2s minus 9 is equal to 0, and therefore we have to find the roots of this equation. Minus 2 plus minus b square plus 4 so after solving 2.16 and minus 4.16. So out of this, we have to check which one is the valid breakaway point. These two should not be valid breakaway point. So this is a trial and error method. We will check which one is the valid breakaway point and which one is not. Okay. So we can write here. We can sketch the locus. So this is 0 is at s is equal to minus 1, and there are the minus 1, this is minus 2, so this is minus 2 plus j3, and this is minus 2 plus g3. Okay, so we have to find the departure angle of departure from this. Okay, so how we can find? So this is how to find this angle. How much is this angle? How we can find how to find this angle? Okay, and we have to subtract this angle from 180 degree. So what is this theta? Theta is equal to tan inverse of 3 by 2. No, tan inverse of 1. So it is a, we have to start from here. So it is a 3 by 1. 3 by 1. So tan inverse of it is a 71.56. So how you can find this angle? So this angle can be found, that is 180 minus 71.56, and this is equal to 108.4. So this is this value. So this is 108.43. So this is this angle. Okay. Now we have to find the angle of departure. How we can find the angle of departure? So angle of departure, phi p is equal to 180 degree plus phi. 180 degree plus phi. And this phi we have to find. Phi is the net angle contribution from this point by all the open loop poles and zeros. So what is angle made by this? So this is 90 degree. Okay. So we have to find by doing how much this angle will be. Okay. So this phi is equal to, what is this angle? This angle is 108.43. As this is angle made by the zero, we have to take it as a positive. Angle made by the another pole is 90 degree. So the phi is equal to, no, angle made by this, yes. So this is 18.43. Okay. Now this value have to substitute here. We'll get the angle of departure. So 180 degree plus 18.43 will get 198 198.43 degree. Okay. So by making an angle of this, so this angle will be, by making angle of this is actually 198.43 degree. By making an angle of 143 degree, this will go in this direction. Again, we have to find the angle of departure from this. So what will be the angle this will make? Suppose it will go like this. So what is this angle? We have to find this angle. So the angle of departure is equal to, from this point, the angle of departure, that is, this is because of this phi of -2 minus j3, and this is because of -2 plus j3, this phi p. Okay. So this angle of departure is equal to this 180 degree minus phi. So we know it is 180 degree, and what is the phi? Phi we have calculated, it is a 18.43. So this angle is 161.57. So this is this angle. This angle is 161.57. Okay. Now we have to So in this way, they will meet here. This will start here. This will meet here. And what is this breaking point? So breaking point is here minus 4.16. So this is a breaking point. So first it will start from this, and one may go in this direction to this open loop 0. Another will start here and it will go in this direction. It will go in this direction. So this is the angle of departure from this open loop poles -2 plus J3, and this is angle of departure from this open loop pole -2 plus J3. So we have to check. Now we'll verify this by using this. Okay. So this is the numerator value. Denominator will be this value, and we'll do the command of the root locus. This is the command of the root locus, and if you find now, we'll get this figure. So this is the first open loop poles. Sorry, this is open loop 0. Okay, this is -1, and this is a first pole -2 plus 3j, and this is another pole -2 minus 3j. Okay, so one will start. So this angle is actually this angle. This angle is actually 198.43, and this angle is 161.57. So this is actually the root locus plot for the given example. Your first branch will start from this pole, and it will come here, and it will terminate at this open loop 0. So value of gain k here is 0, and the value of gain k is here infinity. Second branch will start from this open loop poles. This will come in this direction, and this will go in this direction, and this will terminate at infinity. This will terminate at infinity. So this is the root to locus for the given example. So in this way, we can find the angle of departure for the given example. Thank you very much for watching the video.